Okay, ladies and gentlemen, we're going to go ahead and talk about our scientific thinkers. First, I'm going to give you a little background information before I attack this heliocentric theory slide. Before the heliocentric theory, we are going to have another theory called the geocentric theory, and that was the Earth-centered theory. And an ancient Greek astronomer by the name of Ptolemy is the one who comes up with this geocentric theory. And it was thought that God had put man on Earth and placed Earth at the center of the universe. The sun, the planets, the stars, they all revolved around the Earth. And that man's location in the center of the universe showed his close relationship with God. The sun, the planets, and the stars, they were all God's kingdom. They were made of shiny material not found on Earth. Heaven, located beyond the stars, was where man would be united with God after death. So that was the previous theory until we have this heliocentric theory come along. And the heliocentric theory is going to prove that geocentric theory incorrect. It's going to say that the sun is in the center of the universe and that all the planets revolve around it. So looking at this model, this yellow dot represents the sun, and all the other dots and all the other circles around are planets, and they're all revolving around the sun. So who is the crazy dude who comes up with this? His name is Nicholas Copernicus, and he is a Polish astronomer. He's going to develop that heliocentric theory. He's going to write all of his ideas down. He's going to publish a book in 1543 called On the Revolutions of Heavenly Bodies. But he's going to wait until he is on his deathbed before he publishes his book. And the reason that he did this was because he was so worried that the church was going to persecute him, was going to excommunicate him, and therefore his soul was going to end up going to hell when he died. So he waits till he's just moments from death before he lets his ideas out there to save his soul from going to hell, that his soul was going to be going to heaven. And this was not a good idea. The Catholic Church did not approve of this, and this idea was kind of shoved to the side. And we're going to have a few other scientists come forward after this time period, and they're going to come up with data to prove Copernicus and his heliocentric theory correct. So again, heliocentric theory. And if you break this word down into two, helio and centric, I think we could figure out what centric means. It means center of. And if we broke down the word helio, well, that means sun. So Nicholas Copernicus, sun-centered heliocentric theory. All right, next up we have Johann Kepler. Johann Kepler is going to analyze data from the planetary observations made by another scientist by the name of Tycho Brahe. And he's going to discover that the planets do not rotate around the sun in perfect circles, but they rotate around the sun in ellipses. And an ellipse is an oval-shaped pattern. Okay, so if you take a look at this diagram, the P stands for planet, the S stands for sun, and this arrow is showing you the direction that the planet is moving in this ellipse pattern, this oval-shaped orbit, and it goes around the sun. And the sun's not even in the direct center. It is off to one side, and thus we have what is called planetary motion. And that is that the planets rotate around the sun in ellipses. And Kepler's work is going to prove Copernicus's heliocentric theory to be correct. Next up is Galileo Galilei. He's an Italian scientist. He's going to build on new theories of astronomy. In 1609, he is going to build a telescope that improved the previous telescope so he could study the heavens. Using the telescope, he is going to come up with data that supports Copernicus and that heliocentric theory, that sun Earth-centered theory. Galileo and his discoveries, they are going to support Copernicus. The Catholic Church and Protestant leaders, they're going to be very unhappy with Galileo's findings because it's going to go against their authority. Again, Catholic Church said the geocentric theory is correct, the Earth-centered theory is correct, and anybody who says differently is wrong. So, in 1616, the Catholic Church told Galileo he better stop defending Copernicus's teachings. Galileo's not going to stop. He's going to continue on. And in 1632, he will publish a book that is going to defy the church, and Galileo's going to be arrested. He's going to be brought before the Inquisition in 1633, and that Inquisition is a court, a Catholic court. When you are arrested, you go to court. Under the threat of torture, Galileo is going to sign a confession in which he said he did not believe in the ideas of Copernicus. And he's going to end up living under house arrest until his death in 1642. Take a look at this last bullet. It says, in 1992, the Catholic Church officially said that Galileo had been right. So even though it took him a long time to come forth and finally admit Galileo was correct, at least they admitted they're wrong. Granted, long before 1992, the Catholic Church finally said, that they had agreed that the heliocentric theory was correct once more and more data is brought forth. But it's not until 1992 when they finally had said, you know what, we admit we're wrong. Galileo was correct. All right, next up we have Isaac Newton. Most of you all know Isaac Newton because a lot of you are in an active physics class or even a physics class. And, well, he plays a big role in what you have to learn. So Newton is going to bring together the ideas of Copernicus, Kepler, and Galileo under a single theory of motion. Newton's great discovery was that the same force rules the motion of the planets and all matter on Earth and in space. And the key that linked motion in the heavens with the motions on the Earth was the law of universal gravitation, which we know as gravity. Well, what is gravity? Gravity is where every object in the universe attracts every other object, and the strength of that attraction depends on the mass and distance between the object, or an easier way to remember the definition is what goes up must come down. Newton is also credited with developing calculus. So you do also need to know that calculus goes with Newton. So a lot of you may have seen a diagram like this where you have the apple tree and you have Newton sitting underneath the apple tree. An apple falls and hits him on the head and whoop, he comes up with universal law of gravitation. Well, that didn't really happen, but it gets you thinking what goes up must come down and gravity. All right, we have William Harvey. In 1640, an English physician, William Harvey, discovered that blood circulated through the human body and it was pumped by the heart. I'd like to remember William Harvey by saying heart Harvey. That helps me remember the H starts, or the heart starts with H and Harvey starts with H. So if you could remember heart, which is right here, and Harvey, you'll remember this. All right, so it was thought that before William Harvey came up with this whole, the heart pumps the blood through the body, it was thought that, well, a human body was just like a sack and the blood was just in there It wasn't being pumped, it wasn't being moved, it was just there. So this was a huge discovery, and it is going to advance medical technology. All right, so last up, we're going to talk about the scientific revolution, but more importantly, the scientific method. All right, so remember, we have that emphasis on reason and systematic observation of nature. We're going to have the formulation of the scientific method and the expansion of scientific knowledge. Well, the scientific method, in case you've never seen this before, it is a new approach to science. It uses a logical four-step procedure for gathering and testing ideas. So step one, you're going to have a problem or question from an observation. And with that observation, you're then going to move to step two, which is to form a hypothesis, which is an educated guess. After that hypothesis, you are going to move to step three, which is to test your hypothesis. And you're going to test it by doing an experiment. And after that experiment, you are then going to move to step four. You're going to analyze and interpret the data, and you're going to form a conclusion. And that conclusion, you're either going to approve or disprove your hypothesis. Well, who can we thank for the scientific method? Two people, Francis Bacon and René Descartes. Francis Bacon is from England. René Descartes is from France. And these two important thinkers are credited with developing the modern scientific method. Using their method, science has shown that observation and experimentation lead people to a better understanding of the natural world. All right, ladies and gentlemen, that sums it up. We have talked about our 6 scientific thinkers. Bacon and Descartes count as one in my brain because we have the scientific method, and that is the big idea. So our 6 people, we are going to do light bulbs on them. So you're going to want to make sure that you go back and you look at the diagrams that we have gone over, because you're going to end up drawing those in color in light bulbs. Alrighty. Well, ladies and gentlemen, thank you very much, and I will see you on the flip side.